Hey guys, welcome back to the YouTube channel. I hope you all will be doing well and you guys would be enjoying your life. So guys, in today's video we are going to discuss about the what is the binding energy or the binding energy of the transition element or the first element or the first transition series. So without wasting any time, let's get started. So by definition, binding energy is the amount of energy required to break or vanish the metallic bond among the metal atoms in the crystal lattice is called the binding energy. So basically it is the amount of energy which is required to vanish the metallic bond among the metal atom. If there are metal atoms, so it is used to break the bond between them. This is called the binding energy. So let's discuss the binding energy of transition elements. So the mechanical properties of the transition elements such as high toughness, hardening or metallability or malleability and ductility are due to strong metallic bonding. So the transition elements have strong metallic bonding among their atoms in the crystal lattice. This is because of the partition or the participation of the s electrons of the outermost shell as well as the underlying unpaired d orbital electrons in the metallic bonding. So it means the binding energy of the transition elements directly increase with the increase in the strength of the metallic bonding. Now let's see the trends in metallic bonding energy in the first transition series. So generally the binding energy decreases from left to right in any transition series. So it decreases from left to right if you move in the periodic table, and in the first transition series the binding energy increases from 3b to 6b and decreases from 8b to 11b, and the increase in the binding energy from 3b to 6b is due to the increase in the number of unpaired electrons, and the decrease in the binding energy from 7b to 11b is due to the decrease in the number of unpaired electrons. At 11b, all the electrons becomes paired and there are zero unpaired electrons. Now let's see the figure of the elements in the 3D orbital electronic structure of the first transition series. And in this table there are the elements and there is the 3D orbital electronic structure of the first transition series, and in this column we have the number of unpaired electrons. So first of all we have the scandium, and for the scandium the number of unpaired electrons are the 1, and the second we have titanium, and in the titanium we have the unpaired number of electrons are 1. Then we have vanadium, and in the vanadium the number of unpaired electrons are 2. So there are two electrons in the 3D orbital of the first transition state. Then we have the chromium. So then the chromium we have 3 unpaired electron. Then we have magnesium. In the magnesium we have 4 unpaired electron. Then in the iron we have 4 unpaired electron. Then in the palladium we have 3 unpaired electrons. In the nitrogen we have 2 unpaired electrons, and in the copper we have 1, and in the zinc we have 0 number of unpaired electrons. So this is the tabular representation. Now let's see the binding energy. How does it increases? So the binding energy increases up to the vanadium due to the increase in the number of unpaired electrons. So you can see that the binding energy is increased from vanadium to due to the increase in the number of unpaired electrons, as you can see. Now the binding energy decreased from chromium to the magnesium due to the half-filled stable electronic configuration. So you can see here in the the binding energy from chromium to magnesium, it decreases because due to the half-filled electronic configuration, and the unpaired electrons are not available for the sea of electrons in metallic bonding. Now from iron to nickel, the binding energy increases slightly due to the increase in metallic bond strength, and after the pairing of electron it becomes maximum and the binding energy decreases. So as you can see, from iron to nickel, here is the iron, we have iron, and to nickel the binding energy increases slightly. It increases, as you can see, it increases from, it is the iron and then we have the nickel. So it increases due to the increase in the metallic bond, and after the pairing of the electron the maximum binding energy decreases. So this was all about the binding energy. I hope you enjoyed the video and learned something from this video. Till then, see you in the next video. Take care. Bye bye.